real quick. So how did you guys do on the test yesterday?
Pretty well.
Yeah.
I mean, not as well as I think I would have liked, but it's still well
Yeah,
enough.
that's how I was too. Like
Yeah.
there were only two I had questions about, but then I clicked it and I was like, oh, I didn't do as well as I thought.
Yeah.
But I
Yeah.
did message Brother Papa, and he said on Fridays at 8 o'clock in the morning he does like a virtual office hours.
Right.
So if you have any questions, you could talk to me.
You really want to
It's
go?
really a bad time. I can't meet that time. So,
Oh, that's true. You can't
and
really
I
do that.
could really use the help because I didn't do very well on the test. So I thought I would do better, but I didn't. So I emailed him and I said, I'll try to get a tutor, I guess.
I think they have an online tutor that you can just set up times with.
I did try that, and like our schedules kept on conflicting, and we were like playing tag, and I'm like, I'm sorry, I don't have. So I'm gonna try again. There's only a few that do biostatistics tutoring. So the girl, she would email me back and said, oh, I'm available now, and then I wasn't, and it just wasn't working out. It was a headache. So I'll try again. But yeah, I didn't do as well on the test as I thought I would.
So are you guys ready to start part 2?
Sure. Excuse me. Yep. Sure.
Okay. Well, so it says part 2. You'll fill this out in your group preparation session. You'll do 1 and 2 with your group. Check your answers with the TA when you finish. You know what that means? Like, do we have to contact the TA or do we just watch those videos?
I think. Isn't there a key or something?
Yeah, I saw that, and then there are also videos of the answers, or like of how to do them. So, and I think it's the TA that makes the videos. So maybe that's what the teacher means.
Okay.
Yeah, your virtual TA.
Okay, well, so number 1 says the Graduate Management Admission Test, the GMAT, is used as an admission criterion in many Masters of Business Administration MBA programs. The scores on the GMAT in the past have a mean score of 529. The BYU professor feels now that the score has improved within the last couple of years. Determine the null and alternative hypothesis. Okay. So wouldn't it be like n equals 529 and then like n is less than 529 or something like that? Or greater than 529? No.
Yeah, I put greater than because it means the score's improved, so it's gone up.
So would the null hypothesis be n equals 529?
Yeah.
Is it n? Doesn't n represent the sample size? Is that the right way to write that?
I think you mean like the weird little thing, right?
Yeah.
I think it's supposed to be an M, but it's like a special M. So I put U on mine.
Is it the H and that little subscript O? And then, yeah, like that. Okay.
Yeah.
But I agree with you. Yeah. No, it would be the null hypothesis is the 529, and then you said it's greater than would be the alternative.
Yeah.
Yeah.
Because it improves.
So how would you write 529 greater than sign and then 0?
I put, so if you have like your hypothesis, your null hypothesis is like your H naught, like the 0. So, and then you write like the weird BYU thing, like the mean equals 529.
Right.
And then your HA, so your alternative hypothesis, and I just put like a colon and then just the mean equals greater than, or not
Okay.
is greater than 529.
Okay. Alrighty.
Okay. So then B, suppose you got evidence that the null hypothesis should be rejected. However, in reality, the mean score of students taking the exam is still 529. Was a type 1 or type 2 error committed? Isn't it type 1 because it's still true?
Yeah. Yeah, because if it's rejected but it's true, it's type 1.
Okay, cool.
And then like type 2 is if it's false but it's accepted.
Oh, okay, that makes sense. Cool. Then C, if the analysis was done at a equals 0.01 level, what is the probability of committing a type 1 error? Would we do?
So aren't you figuring out the p-value, which is the same thing as probability, and so you figure out the z-score? Or is that wrong?
As far, I didn't entirely get how they got the alpha. But I think
What does it say on the answer key? Is there an answer to it on the answer key?
yeah, I was just looking at it. I gotta print it up.
Oh, okay. Well, I just looked at the key, and I don't know if this will make any sense to you, but if you look at the key, the answer is there was about a 1 in 100 or 1% chance that there would be a type 1 error. So does the A, or like alpha, does that represent like the type 1 error? So alpha equals 0.01 or 1 in 100 or 1% chance that there would be a type 1 error?
Yeah, I think it means your probability of having an error. Is that kind of what you're saying?
Yeah, that's kind of what I got from the answer.
Yeah, because I think I put on here is 1% just because I was like, well, that's kind of what it looks like. But yeah, but that makes sense to me. So, oh yeah, right here it says probability of committing a type 1 error, in which they usually use is the 0.05 because it's 1 of 20.
Yeah.
But they're using a different number because they decided to use a different number, I guess.
Okay. And then D is if we wanted to decrease the probability of making a type 2 error, would we need to increase or decrease the level of significance?
I put increase because it was saying how like the 0.05 kind of balances it more. So I was thinking it kind of must kind of go hand in hand. Like if it's 1% on this in the type 1, then it must be like 0.9%, maybe.
Okay. Yeah.
I'm not entirely sure how they did that, but
And in the textbook, in 4.4, there's a little saying or quote. It says, if the P is low, reject the null. So yeah, so if we want to decrease the probability, okay, I'm just trying to figure out how to explain my thought process.
I know, it's kind of like the concepts are longer and harder to read.
So if we wanted to decrease the probability.
Good night. I can't right now.
But,
I can't in the middle of class. Good night. I'll have to do it later. I'm still awake.
okay. Well, so number 2. This one's a
Okay,
little
I'm sorry. What was the final answer on that?
Oh, it's to increase the level of significance.
Okay. And can you explain in your own words what the level of significance is? Is it just basically means when the probability is low that the rejects the null hypothesis? Is that what that means?
So the definition says a number that can be used to determine if the p-value is small enough to reject the null hypothesis.
Okay.
So it's just a number that we can get that's small enough to say, no, this hypothesis is wrong.
Okay.
So like if the chance is so low, like we got earlier in that one problem, it just said that A or alpha equals 0.01.
Mm-hmm.
It's like, well, the chance is like, that's a 1% chance. So that's so small, it will occur 1% of the time that the hypothesis is incorrect, or it's not very good.
No, so
Good night. Love you.
I don't know how I'm saying it either. But yeah, the null hypothesis is the status quo, so it only says that it's a low enough number. It's only, like 1% chance of that happening, and so you reject it because it's not. It doesn't happen. It doesn't happen enough.
Yeah.
Right. So you said decrease for D.
It would increase.
Increase?
Yeah, we would want to increase that. If we want to decrease that. Okay. So let's look at the type 2 error is, where'd it go? Where'd it go?
That's when
the null hypothesis failed to reject, right?
Yeah, you fail to reject the hypothesis, but it is false.
Yeah. Oh, okay. Yeah, gotcha. Okay.
Meaning false that the null hypothesis still is still correct. Is that what you mean by that?
No, the null hypothesis isn't correct.
Okay.
But they didn't reject it.
Okay.
When there should have been enough evidence against it.
Cool. So number 2, a study by the National Association of Realtors reported in 2004 that second home sales accounted for more than a third of residential real estate transactions. According to the report, the average age of a person buying a second home as an investment rental property was 47 years. Assuming the national standard deviation was 5, a real estate agent wants to determine if the average age of those buying investment properties in his area is different than the national average. He randomly selects 15 of his clients who purchased an investment property and brings the data shown. Okay, so that data. Letter A. Design the study. What is the population from which the realtor obtains his data? How did he sample this population? What is the research question? Okay, wow, I need a haircut. I saw myself, my hair's getting long. Anyway, so the population, isn't that just all the people buying a, what would we say?
His clients, that's the population, isn't it?
I think the population is the
people
National
buying,
Association, their
National.
information. Because he takes his sample is his own clients, right?
Right.
But he's
yeah.
comparing it to the population, or he would compare it to a population, and he's comparing it to the national average,
So the
average age of a person.
So the population is a national average.
Yeah, that's kind of how I understood it.
I'll go with that.
Oh, I understand it too. And then, so the sample is his clients, and then the research question is like, what is the average age? Right, it says, a real estate agent wants to determine if the average age of the, so what is the average age of the people in his area that buy a home for an investment property? Something like that.
Yeah. I think I just put if it's different, but I think kind of a yes/no question is probably what they're looking for more.
Oh, okay.
So just like what you were saying. So what's the average age of those buying investment properties in his area?
Cool. Oh, okay. So on the answer key, it was kind of in between both of our questions, or like our answers. What the teacher put was, is the average age of the people buying a second investment property in my area different than the national average?
Okay.
So, cool.
Okay. Yeah. I put something like that. Close enough that I understand what it means.
Yeah. Cool. And so B, collect the data. Name at least one way the realtor could have randomly selected his sample. He could have put like the buyer's ages in a shuffling thing on the internet to give him those 15 names or 15 ages of the buyers.
Like a random number generator.
Uh-huh.
I think I put systematically because I was looking at how he kind of did it before. We were saying randomly selects 15. I don't know. Somehow I got that systematically.
Okay.
But
Isn't systematically where they
like
get it from different, like if you were to break it up in the neighborhoods and then get one from each neighborhood or something like that?
No, I think that one's stratified. Systematically is like you choose every third or every second
Every
person.
K number item.
Yeah. Okay, cool. Yeah. Cool. Then graph the data on a histogram. Sketch the histogram below or cut and paste your electronic copy. In a short paragraph, describe describe the data by using at least 5 distributions. Well, I'm just curious. Is there an easy way to put it in Excel or something?
I copied the data. I used SPSS though.
Oh, okay.
I just put it in there as a column and made a graph.
Okay, I will do that.
But you could probably do it with Excel too. I just didn't do it with Excel when we started using it, and so I now use the other one.
Okay.
So okay. Put in the numbers. Just
Yeah,
put them in one column, right?
Yeah, I just put them in one column.
Yeah.
Um,
Okay, so Victoria, did your histogram look more left skewed?
Yeah,
Yeah.
yeah. There's like a kind of two big bars on the right with a little one in between,
Hmm.
and then kind of a middle-sized one going to the right, and then a little one.
Are we supposed to cut and paste it somewhere?
I just copied it and then put it into the document.
Okay. Guess I should give a title to it. Okay.
oh, that's cool. I don't know.
I feel like even those are kind of like, I don't know, concepts are harder to do for me
Yeah.
anyway. I feel like it goes faster when you're actually doing the homework though. Because you can just be like, this is the null hypothesis, this is not, this is what it's asking. It's not a lot of calculations.
Yeah.
I'm gonna say that, and then the test is gonna be all
It's just the
calculations.
calm before the storm.
Right. Right. It's true.
All right, I cut and paste my histogram. Everyone else, where are you at? As far as
I'm just writing that short little paragraph right now.
yeah, the 5 descriptive.
Find descriptives, yeah.
Yeah.
So what were the five descriptions that you put, Victoria?
I didn't do that earlier.
Oh, oh,
I just put the mean and standard deviation this time. I was just looking at what I should put.
I put
oh,
it's left skewed. The mean is 46.73. The standard deviation is 8.827.
Yeah.
The sample size is 15. Um, let's see, that's 1, 2, 3. I need one more description.
what did you say the standard deviation is?
8.827.
Oh, okay. The sample size is 15.
Guess I put in a number incorrectly.
No, that's what I got.
Okay.
And then let's see. The maximum is 58. We could say that.
Yeah, yeah, 58. I guess you could do a box plot if you wanted to.
Yeah.
I think your box plot is your, what do you call that? 5-number summary? Maybe that's all
Yeah.
it's asking for.
Right.
Right.
Okay.
Can you guys
So
hear
are
the
we ready
train?
for D?
Has it been cold where you guys are at? It like warmed up a lot here. It's been warm in the 80s.
Wow, it's in
Wow.
Yeah, yeah. I mean, I do live in Southern California, but I do live up a little bit higher elevation, so it's actually kind of warm. Yeah, I'm drinking more water. It's warmer. Okay.
It's like, I guess it's gotten warmer, but it still gets foggy sometimes. We get a lot of fog.
Oh, really?
Yeah. Because we're closer to the mountains, so it's like
Ah.
all the fog just goes right there. The beginning of January, we had like a week where I couldn't see our backyard. It was pretty. I was like, I feel like this microphone's really canceling out, but I can hear the train.
I can hear the train too.
Yeah.
Very subtle, but since you mentioned it, I could hear it.
Yeah.
So, I don't live that close to the train, but it's close enough that my house kind of rattles enough.
Oh,
When
really?
it goes by, I can hear it, but I'm not that close. But we live in the desert, so there's really no sound barriers per
Mm-hmm.
se. So everything seems a lot louder than it really is, or closer than it really is, because there's nothing to really block it. It's
Yeah.
flat. So
No, we don't. Our house doesn't rattle. It's like we're in the middle of the neighborhood that's at a corner, and then the two streets, the train crosses right through them. So,
uh,
so it's kind of like on the other side of a couple houses, but yeah. Anyway, math.
You guys ready for D?
sure.
Um, so letter I. Well, number one, I guess. Says check the requirements. Since there are only 15 pieces of data, what will you need to check? Would we check like the the alpha thing?
I think you're supposed to check if the population is normally distributed. It
Oh,
had a requirement for the hypothesis test for a single mean with the standard deviation known. And so the data represents a simple random sample from the large population, and then you have to make sure it's normally distributed. And since the sample size isn't large enough, we have to make sure the population is normally just the parent population is normally distributed.
okay.
I can find it in the book real quick if you'd like. I think it's under 4.6.
So did you get that it's normally distributed?
I did. I just put the population is normally distributed. Um, how are we checking that? Oh, is it with the histogram? I didn't even think about that. I guess it wouldn't be normal because it's more skewed.
Right.
Okay.
Right?
Yeah, that makes sense.
Yeah, I didn't even think about that, and I just
And
went
that's
on.
what's in the textbook when they were using the example of that boat, Ethan Allen, where it
Yeah,
said to go through the steps is to first make a histogram as one of the steps, and then pursue it or whatever. Go through the statistical steps.
yeah. Or wait,
And then,
the histogram is the sample, right? So it's not the population. Sorry, I think I'm confusing myself more. I don't know. I think we can just. I'll just leave it alone.
um, so which one are we on right now?
We were just finishing the first one.
Oh, okay. Gotcha.
Sorry, I was like getting confused for a second. And yeah,
It's okay.
it's okay. Thanks.
Yeah, I need to cut my hair.
like looking in a mirror, huh? When you're on, on Google Hangout, you're like, oh yeah, look at me, yeah.
As long as
Yeah, I actually fixed my hair today. I had time. And put it back in a ponytail. Okay, so double I, state the null and alternative hypothesis. Is this a one or two-tailed test? So would the null be the mean, taking all those numbers and figuring out the mean? Would that be the null? And then alternative hypothesis is testing that.
Yeah. I was looking at the national. I was comparing it with the.
Okay.
Yeah, the national. So I did the null hypothesis was the national average. So the mean equaled 47.
Oh,
And so
okay.
what he's testing is the alternative. He's testing that, but his alternative hypothesis is that the area, his area that he works in is different than the national average.
Okay.
So that would be like, since you don't know whether the mean is greater than or less than the national average, it would just be the mean is not equal to 47.
Okay, so what's my notes? So that means it's a two-sided hypothesis and it's two-tailed, a two-tailed test.
Yeah.
All right.
So then for like 3i, I don't think we have to do anything for that, do we? It's just kind of like an instruction.
Yeah,
Right.
I think it's just an instruction.
A number to plug in for number 4.
Okay.
So we have to use our z-score formula.
Mm-hmm.
Yeah, in number 4, yeah.
So would it be 46.3 minus 47 over 8.2? 8.27?
I think I have the wrong sample mean. I didn't figure it out.
So then wouldn't we do 8.827 divided by the square root of 15? Let me see.
Yeah, that sounds right. On the bottom, the 8.827, which is the standard deviation, divided by the square root. What is the sample size? It's 15, right?
Yeah.
So 15. And then, so it was 0.05 is the observation, the x.
Wouldn't we use the national standard deviation?
Yeah, I think you're right. Yeah.
Okay.
Right back.
Good job.
That one was 5, right? It should be
5, yeah. Good job.
I messed up on the sample mean. For some reason I didn't figure out that the sample mean and like the mean meant, I don't know, it was weird.
Okay.
I was just being dumb for a little bit. This one says 46.73. I just like added them all up and divided it and got something totally different.
Yeah. What did you get, Victoria?
When I did it with the other number,
Or
I'm calculating the other one right now.
oh, okay.
just 1 second.
I want to know if I have it properly set up. So on the numerator, you have what two numbers? 0.05 minus the mean?
I
I'm confused.
have 46.73 minus 47.
Oh, okay.
So, yeah, you don't use the alpha yet. You use it just like a normal z-score.
Oh, so why are they giving us that number?
I think it's for later. You have to compare
Got it.
it with the probability.
Okay, and so in the denominator you have 8.827 square root of 15, right?
I did 5 divided by the square root of 15. Because that's
Okay.
the national
Oh, okay.
standard deviation. And I got a negative 0.209.
That's what I got.
Okay. I'm going to check it with the key just to make sure. Okay.
Yep, that's what it says.
Yeah, so I did it wrong the first time.
Yeah, me too. Oh.
Yeah, negative 0.209, you said?
Yep.
Okay.
Sorry, my thing's gonna be noisy. Okay.
Okay, so we're using the applet for number 5. Okay.
I would be so excited. That would be so cool.
So when we do the applet,
Mm-hmm.
we have both the tails highlighted, right? Because of the two-tailed.
Yeah.
Okay. Okay. Yeah.
Need to pull up. Oh my God, I already have it. What's that? And
So you had 0.8344?
Yep. Yeah.
Okay.
So I think the next one is where we use the alpha.
Okay.
Mm-hmm. Mm-hmm.
Compare the v-value to the level of significance. The A level. Okay.
So in that one, we're just comparing the p to the p-value to the alpha, right? And so the rule is that if the p-value is less than alpha, we reject it, and the p-value is greater than alpha, then we fail to reject the null hypothesis. That's what I have down. Little girl.
So what did you guys get for the value?
For 5?
Uh-huh.
0.8344.
Okay, that's what I got too.
Okay, so we failed to reject it because the p-value is lower than the p-value. I mean, the value is greater, excuse me, than the alpha level or A level.
Yeah. So it happens more. So that must be the normal thing that happens. So it stays with the status quo for the null.
Right. So 47 is still like the national or average age that someone owns an investment property.
Yeah. So I'm gonna change my thing though, because I did it before, and I used the wrong sample mean, and it was all different.
Okay.
Makes more sense now.
In my mind. Mm-hmm. Yeah, it said I read it today. It's exactly. It says it's true, but if you go to the pending, it's still there. Yeah. Okay, so it'll probably go in tomorrow. Okay. So are we on number 7?
Yeah.
Yeah, we were just writing it down.
Okay. No, because we feel like when we go to Idaho, we're going to pull out the money out of our checking account. So right now, we can just transfer it. And transfer it, transfers from most far to most far order immediately. So, I think we're everything. Oh, I think he does it all guidance. So,
So would you put Victoria for taking action?
I put that he should like suggest buying investment property to people that are around that age.
I said kind of the same thing. I said the realtor should appeal to his clientele that is in that age group.
Yeah.
that's what I said too.
Alright. You think we all understand it enough then?
Oh yeah, I can't right now. I can't. Alright, you can drink my water if you want. You should be in your bed, sleeping. All right, are we all on question 3 of the quiz?
Oh, on the quiz. I was like, on the preparation or something else? The quiz, I'll pull that up real quick.
See if I can have both screens up, but I still can't get them both up. Let's see if I can do it.
Okay, so number 3 is the null hypothesis, right?
That's what I did.
Yes, we're in the status quo.
And then isn't number 4 also null hypothesis?
Yeah.
Yep.
So p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this information to answer question 5. When computing this probability, which hypothesis is assumed to be true? The null.
Alternative.
I think you assume the null to be true even though you're testing for the alternative. Does that make sense? Probably not.
I thought I read that you assume the alternative to be true. I don't know.
I'll look in mine. So we've got
I have in my notes the null hypothesis. Here, let me put myself back on the screen here. The null hypothesis status quo involving equality, and the alternative hypothesis researchers suspect is the actual truth. And that was referring to the Ethan Allen vote and the weight capacity and how many were actually on that vote and that kind of.
yeah, I think.
But so if you wanted to verify that in the textbook, that's where I found that information.
Yeah, Like in step 1, the last paragraph, it says when we
And then-
test hypotheses, we assume the null hypothesis is true. So I think we're trying to kind of prove that the alternative is true,
Okay.
but we're gathering evidence against the null, but
Okay.
we assume that the null is true. It's kind of like turned around. I'm gonna go unplug the dishwasher real quick.
Thank you so much. Sorry.
Okay. Sorry.
Sorry.
Our dishwasher goes off, and it will beep forever if you don't undo it, and it drives me crazy. And so
The microwave. If there's something in there and you don't take it out, it'll keep on beeping, reminding you to turn it off or to take out whatever in the microwave.
yeah.
Okay. So number 5, we're saying it's the null hypothesis.
Yeah.
Number 6, which of the following represents the alternative hypothesis for a two-tailed test?
So a two-tailed test is the equals or does not equal, right? That's what I have in my notes.
Right. That means it's
Okay, so would it be
equal or not equal. Yeah. So it would be C, right? The third choice.
Yeah,
the
so-
U is equal or doesn't equal
Doesn't-
10?
Yeah.
Okay. And then number 7, following the left-tailed. Would that be the U is less than 10?
That's what I put. I always kind of remembered like the
Yeah.
it's like the arrow points to the direction of the tail.
That's what I have in my notes. One-sided hypothesis, left-tailed. So it's U less than 10,
Cool.
which would be the first choice. Correct?
Yes.
Yeah.
And then number 8 is just the opposite.
Right. Correct.
Oh. Would number 9 be the p-value is greater than A or less than A?
Let's see. I always start getting them confused. Greater than. Yeah.
Okay, that's
Because that means it happens more often. The probability of it happening is more often.
So it's choice 1. P-value is greater than A. The
Yeah.
lowest.
Okay, and then number 10, which relationship would result in rejecting the null hypothesis?
So that'd just be the opposite.
Okay.
Right.
Less than alpha.
It would be second choice. P-value less than significance or A.
Yep.
Are we all reading number 11 silently to ourselves?
Yeah, I think so. Which of the following would be the appropriate alternative hypothesis? Would it be less than?
I thought greater than.
I think it is greater than, because they say that
Actually,
the is actually higher than this.
right.
Oh, okay, that makes sense then.
So third choice is what I have.
Yeah, me too.
Okay.
And then would number 12 be the less because it's the null?
The null is always equal. It involves an equal sign.
Oh,
So yeah, the average claim amount was 1,500. So
Oh, that makes sense. Yeah.
So it's choice 1. The average
Yeah.
claim is equal to, yeah.
Okay. And then number 13, it would be yes.
yeah,
I would say yes because the sample size is large.
yeah,
Uh-huh. And then what theorem? That is the central limit theorem, right?
yes.
Yeah.
Then 15, which of the following is the test statistic as defined in the lesson?
That's the z-score, isn't it?
I think so, yeah.
Yeah, I think that's what I have in my notes too. Yeah. Choice 2.
Yeah.
Okay, and then for 16, do we just find the z-score?
Looks like it. I haven't finished reading the question or whatever.
Yeah. It says, what is the z-score associated with this test? Excuse me.
So would it be 144 minus 150 over, where'd it go? Oh, 40 divided by square root of 36.
36, yeah.
So did you get,
I got negative 0.9.
that's what I got, yeah.
I'm still figuring it out.
Don't forget to round to 3 decimal places.
Yeah.
Yeah, 0.9 you said?
Mm-hmm.
Okay, I'm doing something wrong. How am I doing?
Did you do the 40 divided by the square root of 36?
Yeah, I did. Maybe I'm calculating wrong.
Hey, and then
Okay, now I got it. Nice. Do an extra step. The negative 0.9.
And then for number 17 for the p-value, do we find the ones on the outsides?
I think
The tail.
not for this one, because it's just less than, so it's only a one-sided.
Oh, okay.
So it's everything to the left, because it points to the left of that z-score.
So did
So
you
we're
get
gonna
0.1?
take. Okay, so we need to use our applet. Okay.
Yeah. So I got point 1841.
Cool. That's what I like. But be sure there's 3 decimal places.
Yeah.
0.1841, you said? Yeah. So you said everything on the left of it, and how did you determine that?
It's a one-sided.
One-sided.
Yeah, it's one-sided, so you only have to do stuff that's the arrow points to the left. You only have to do stuff to the left of that z-score.
Okay. So answer 1, 4.
And then for number 18, would you just reject or fail to reject the null hypothesis?
Well, what is our
Um,
total significance? It's 0.05.
and it's greater than.
Yeah, it's greater than.
So you fail to reject it.
Yeah.
Okay.
Our p-value is greater.
And then number 19 is type 1, right?
Yeah. Yeah.
It involves rejecting the null hypothesis when the null hypothesis is true. The researcher decided that instead of using a level of significance of A equals 0.05 times 1, which is which probability of type 1.
19 is type 1, right?
Yes.
Okay. This one will be true.
So then do you think 20 is the probability that the null hypothesis is true will decrease?
I think the what was I reading? Because I
If
think
the p-value is low, you reject the null. That's the little thing you're supposed to memorize, the level of significance from 4.4.
yeah. So it
If
would.
the p is low, reject the null. Okay,
Yeah.
so but how does that apply? Let's see.
So the p-value would have to be less than 0.01,
Right.
which is going to be very rare. So you wouldn't reject it, so it would be true. So it would increase, wouldn't it? The probability of the null hypothesis being true? Or
Yeah. Yeah, I think it would increase. It would.
So would it be the type 1 or type 2 will increase?
I think type 2.
Okay.
Instead of using. Yeah, because I think you're only testing for type 1 in your alpha or your level of significance. So, yeah, because of at 0.05 they balance out, but if you make the type 1 lower, it's going to increase the type 2.
Okay.
So it's the second choice.
Yeah.
Yeah.
Okay, then number 21. If A equals 0.05, compute the probability of committing a type 1 error. Wouldn't it be 0.05? Or would it be 0.95?
I don't know that one.
Yeah, I don't understand. The level of significance is the same probability, right?
Mm-hmm.
Okay. Yeah. Alpha equals probability of committing a type 1 error.
Okay,
So,
so it would be 0.05.
yeah, so it'd be the same thing.
Okay, well, are we ready to submit it?
I think so.
Yoo-hoo!
Still waiting. Woo!
Got 100. Good job.
I have to go to my screen so we can do our virtual high five.
Oh, yeah.
I'm starting this and I'm not letting it go. Okay.
It's a fist bump. There we go.
Oh, yeah. Oh, you can't say fist. Okay. Like,
All right.
you guys want